Now this next layer here is complementary to here. So this is the first time, the first layer, that we have to do things in isolation. So what we're going to do is we're going to take a look at the conformation that we have here. And we're going to solve it like the corners. We showed what to do in this particular situation. We're going to look at these as though they're corners. So find two corners that are in. If you don't find any corners that are in, then just pick a random side and do the algorithm. This is going to be my R. We're going to do the corner switching algorithm, rather the corner swapping. The corner switching is when you went like this. Corner swapping is when you're swapping on one side. Switching is from one layer to another. Swapping is within the same layer. So just do it randomly and do 2R U, 2R UI, 2R. Then you do UI DI, rather D, 2R UI, 2R U, 2R. Once you've done that, you look around and see if you put, and then of course, sorry, you move this back. You see which corner pieces are in. We have this. You should find the one that's in. Then turn it over here. Now normally what you do is you'd move this to the left side, right? Move it to the left side and then do the corner swap again and everything should be in. But the difference is you might not have what you need over here. In order to do the swap and do it successfully and have everything in, this orange, I need to have the other orange piece over here, but I don't. I have it over here. So it's not going to work. If I do the corner swap again, I'm just going to put the green one here, so it's going to be orange-green. This is going to end up here, and this red is going to end up over here. So we're not going to get any closer to what we need. So what you're going to do is keep this to the left, and now what I need to do is I need to swap both of these two as edges with each other. I need to do an adjacent edge swap. Now alternatively, what I could also do is I could do an opposite edge swap. It doesn't really matter, because consider what's going to happen. If I do an adjacent edge swap, then this red is going to be here and this red is going to be here, and then it can work. If I do an opposite edge swap, then this yellow and green is going to be here, which means I'll have this green is going to end up here, which can swap with this. So whichever one you feel comfortable with, whichever one you want to do. Keep this over here and either do an adjacent edge swap or an opposite edge swap. It doesn't really matter. You're reconfiguring the position of these edges. I'm going to do an opposite edge swap because it's just easier to do. Now understand what's going to happen. Anytime I do an edge swap, I'm going to be basically causing placement issues. This is going to be, the middle layer is going to be messed up, and these are going to be up over here. So bear in mind that that's going to happen. So with the edge swap, 2R, 2U, 2R, 2U, 2R, 2U. Okay, so be wary of the fact that these have been swapped, but don't worry about that for now. Because now I can do the corner swap because I've got the green here and the green here. So go ahead and use these as corners. We were using these as edges by doing this as the 2R before. Now we're going back to looking at these as corners so that I can reduce both of these centers here. So we're going to do an adjacent corner swap with these two and not an edge swap with these acting together. So I'm going to go ahead and do the corner swap. Now remember, just move this layer over here. So it's going to be 2R, U, 2R, UI, 2R, UI, DI, 2R, UI, 2R, U, and 2R. And this moves back where it was. Okay, so now you got it. Now all these are in. Now what about the placement issues that I created over here? Well, that's okay. What I'm going to do now is do another adjacent edge swap, because now that I have these reduced, I really don't care about the position of it as of yet. So now I'm going to do an adjacent edge swap looking at these as edges now. Instead of looking at these as corners, these two as corners, I'm going to look at these collectively as reduced edges, do my R move over here, and do an opposite or adjacent edge swap, whichever you want. That's going to be 2R, 2U, 2R, 2U, 2R, 2U. So that gets this back, and now we've reduced the edges here. So that reduces these. Now, that was one scenario that you can have. In this scenario, I had two corners that were in, and then I had the rest that weren't. I had one corner set that was in, the rest weren't. I had to do an adjacent corner swap, but the one that I needed here was over here. Now, it might not happen that way. You might have it actually where it's supposed to be, in which case you didn't have to do all that. So that's the easiest scenario. The second easiest scenario was the one that I just showed, where to do the swap, the proper piece wasn't here, it was here, and all you have to do is do one type of a corner swap, and then you can go ahead and do it. But there's another scenario that's the hardest of them, which will look a little something like this. Well, something like this. So you see that there's this that's in, this is out, and uh-oh, this is in too. You have two that are in. Well, this is a little bit of a problem because you can't have both two that are solved, because even if I were to do an adjacent corner swap, I'm going to end up swapping this out too. So I'll put another one in, and I'll still just have two, but I won't have all of them in. So this represents a little bit of a problem. This is not unlike the floppy parity that we have, but I can't handle it the same way, which is usually done by a series of Red Bull algorithms. So what do I do about this? Well, the first thing to do is go ahead and move these opposite each other. So I want this to be opposite this over here. I'm going to achieve that by doing an adjacent corner swap to our adjacent edge swap rather, to our U, to our U, to our, to U, to R, to U, to R, U, to R, U, I, and to R. So they are opposite each other, but because we did an edge swap, we caused placement issues here. So I'm just going to do an opposite edge swap just to get this placement parity out. To R, to U, to R, to U, to R, to U, just to eliminate confusion. Now, the reason why this occurred had to do with the fact that I was free and easy with whichever pieces I wanted to put in over here. And this is where we run smack dab into the problem of false equivocation. Because the problem is, I said that this piece is exactly like this piece, and I put this piece in. The puzzle doesn't want this piece to be here. It wants this piece to be up here. It wants this piece to be down here, and that's how this occurred. Because in reality, I need to do a swap. I need to swap this and this. I need to swap two, but I can't just do that. So what I end up having to do is swapping these two, and then swapping these two. So we're going to want to coordinate something like that. Now, kind of stick with me with this, because here's how we're going to get out of this. What I want to do is I want to go ahead and swap a couple of pieces here. This I want to put into over here, but at the same time we're going to be swapping another piece down here. I don't have a fancy algorithm to do that, but here's a strategy that I use. Let's take these two and move it down like this. So you're going to do a 2B in order to place that where this can match with this piece over here. But let's think what's going to happen. If I do that, I'm going to destroy this over here. But I don't have to do that if I put another green piece over here. I don't have another green piece to put in because it would have been this. So I don't want to destroy this yellow set here. But that won't happen if I put a yellow set over here. I do have another one of those, which is this. So what's actually going to happen is we're going to be swapping this with this. That's what's going to happen. So in order to make the clean swap of this to here and this to here, then we're going to have to swap these two. So to make sure that this doesn't get destroyed in the process, because I'm going to go like this, right? And this will be fine. And this will be fine, but I've now destroyed my yellow. So I'm going to take this yellow, or whatever piece is complementary, whatever color is complementary to what you happen to have over here, and I'm going to take that and put it over here. It's going to mess things up a little bit, but that's okay. We need to reset the puzzle anyway. So to do that, I'm going to put this over here, double turn, move this in, and turn back before I cause too many issues over here. So what I've done, don't worry about what's happened over here. As long as they're reduced, we're okay. This yellow is here, and this yellow is here. So that means I'm now free to take this green and put it here, and it won't destroy these yellow sides here. So I'm going to go like kersplat. So this is in, this is protected. this is protected, and this is in. Don't worry about what's happening here. This is all going to be fixed. But the problem is I need to turn this back because these centers are out. So in order to turn these back, I've got my yellow complementary pieces here and here. Now I have to do similar complementary pieces here and here. Well, I've got a green piece over here. I got a red piece over here. What if I just took this green and moved that to here? So I'll have a green complementary piece down over here. So then I can move this back, this gets in, this gets back, and everybody's happy. Alternatively, what I could do is move a complementary red piece over here. And it might be easier for me to coordinate that. So that's what I'm going to do. I've got a red edge center piece over here. I'm going to put one over here, which is this. So I'm going to move this out, substitute it with this piece, bring it in, and then quickly move it back. So now what I can do is I can fix what I just did over here. I'm now going to take this and move this layer back like so. And voila. Good, 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 and good. These were all protected. And now that I've done that, I can simply take this and move this back over here. Now we've got some damage control to do. So what I'm going to do is I'm going to move these back in to as much as I can. And it looks like much of this was taken out. What I'm going to be doing now is I'm going to replace this side over here. Kind of had to be done because of the parity that that had occurred. So I'm going to take this. I'm going to move these down to over here. So take this out of the way. I'm just going to double turn this here. Move my green side here. Now you're probably going to have the entire thing on block still there, still fixed, and move this in. So I've got this okay. Now I've got to put the red side in, which will be probably this one here. So I'm going to turn this like so, double turn, move my red center in, and double turn it back. So this center is good, this center is good. Now the orange center, I need to put my orange center in here, and I think I'll take it from this over here, this orange over here. So move this up. I could move this one in, but I think I'm going to move this one in because it looks like more pieces are solved, and move it down. So I've got just about all of these down here. I'm just going to bring them in from the top. So green and red right over here to our U, to our UI, to R. You've got placement issues here. Move this in, orange and green, which is going to be this one, which will come here to our U, to our UI, and to R. And this moves in over here. So now we have one more, but be careful, we don't want to cause placement issues here. So let's find the one that goes here, which is not this one. It's this one. But it's going to create placement issues, so I'm going to put a dummy one in first, to our U, to our UI, to R. Then move this one in to where this will come into here and fix it, to our UI and to R. So this has now been fixed, and this has now been fixed also. So basically, this is a situation that was the hardest of situations should you have two that are in and two that are out. I don't have a quick Red Bull type algorithm to fix that, but basically it's a matter of just using the technique that I do with my reductive strategy to put that in. A little bit cumbersome, but there it is. So now I'm looking for the two corners that are in. These two are in. So I'm going to move this to the proper corner. Then do a corner swap. Parity has been taken out, so the other yellow one must be here. This is my R to our U, to our UI, to R, UI, D, to R, UI, to R, U, and to R, and this comes back in. Okay, so all the corners are in, and now it's just a matter of doing edge swaps. swapping these two. Now here's the problem. I have two that are in fine and two that are not. If I had, if these two are out and these two are out, that would be easy because I'd swap these two, which would create placement issues here and at the top and the bottom. Then I'd fix that by putting these two in. So the problem is, if I just have two that are out, I'm going to end up with placement issues between the middle and the top and the bottom. So how do I get rid of this? Well, what I'm going to do is I want to take the two that are out and put them opposite each other. So I'm going to go ahead and do an adjacent edge swap to flip these. It will flip these wrong, then I'm going to do an opposite edge swap to get these back and put these out once again. So just go ahead, if they're next to each other, do an adjacent edge swap to our U, to our U, to our, to U, to our, to U, to our, U, to our, UI, and to R. So it might seem that this layer is fine, it's fixed, it's good, but we sacrificed other layers. So go ahead and do an opposite edge swap to move these opposite each other and fix these to our, to U, to R, to U, to R, to U. Okay, so it fixed these. Now why did I do that? I did that because when you have these two opposite each other, I have a parity fixing algorithm that'll flip these two. It's completely within the law of cubes to do that because you're basically swapping two things. You're swapping these two and you're swapping these two. The way that you do that is you hold it to where this is on the left and this is on the right. This is going to be a U move, and this will be also a U move that'll come in, and I'm going to be doing an F move over here. And the way that you do that is you do my infamous URF algorithm, where you're going to go to UU. I'm going to call this a UU and this a U. So it's to UU, to R, that's an R, and then our to F, then to UU, and then to U, just with the top, and then finish it up with to F, to R, to U, and that's the classic parity fix with that. So you've now done this layer, and that was the toughest of layers. I went through what I think are all the possible scenarios that can happen with that, specifically the edge issues, whether it's one edge in and everything is fine with coordination with each other, or one edge pair in and you have to actually move something to the other side, or if you have two edges in. So now the last layer, well, I'm not going to have the same kind of parity because there's no equivocation. I knew exactly which was supposed to go where. So too, find two of these edges that are in. It's these two. Now we do an adjacent edge swap. Once again, you can see that this is not correct because the green one is here when it should be here, so that it can be swapped over to there. So go ahead and do any kind of edge swapping to reorient things. You can do an adjacent one, you can do an opposite one. I'll do an opposite one. To R, to U, to R, to U, to R, to U. It created our placement parity here. Don't worry about it because now we've got the edges properly configured. And now we use these as the 2R because we're using these as corners. These have now become corners. Once we get them reduced, these will automatically become edges, but they're not there yet. We still have to reduce them. So we do the corner swap to our U, to our UI, to R, UI, D, to R, UI, to R, U, to R, and lo and behold, we have that in. Now, quick as we can, let's go ahead and, this will come back here. Let's go ahead and fix this. It'll do an opposite edge swap of these two, but that's okay. We just don't want to have this placement parity here. So we'll go ahead and do another opposite edge swap. To R, to U, to R, to U, to R, to U. Okay, so these are all reduced. So now we do the corners the same way. These two are in, move it to the left side, and we're going to do an adjacent corner swap to our U, to our UI, to our UI, DI, to our UI, to our U, to R, turn this in, and we're good. Or are we? Well, we have the same problem here. If we had these two that were out and these two that were out, Well, we'd swap these two, creating placement parity here. Then we'd swap these two to get it back. But we have once again the same situation. The handling of this is exactly the same way. Swap these and then put them opposite each other. To our U, to our U, to our, to U, to our, to U, to our, U, to our, UI, to R. All right, you can see that these are wrong. So what I'm going to do is I'm going to swap these two. So we'll go ahead and get out of this. That's going to be to R, to U, to R, to U, to R, to U. Now with these solved, I now have these opposite, and it's the same parity fixing algorithm. Hold one to the left, one to the right. This is going to be my F move this time. Instead of this, when it was in the middle here, it's going to be to UU, to R, to F, to UU, to U, and then to F, to R, to U, and it's done. Now, there's one other scenario that I didn't quite go over as you're putting these in. Sometimes you're going to have a situation where this layer is in, this layer is in, but when you put this layer in, these two were out. These two didn't work so good. This is that situation of what I'm talking about. Something like this. Now this whole thing is solved, but basically you may find yourself, this is solved, this is solved. But to get this in, we ended up maybe with two that was here, that was swapped. You're going to end up with potentially a situation where just these are out. Well, what can we do about that? That looks like an impossibility with the law of cubes. But it actually isn't, because to swap these means we just have to swap these two, say, en masse. And then we can just swap them as pairs after that. So these two will then swap and these two will then swap. So if you can picture that, these two will swap, and at the same time, these two which are looked at as one these two which are looked at as one edge pair get swapped. Well, we can swap those back by looking at these individually as individual edges. One swap, two swaps. Total number of swaps, 1. And these over here, 2, then 3 and 4. So when you get this situation, if you end up with this, for whatever reason, here's how you do it. You're going to do the same type of URF algorithm, but you're going to skip one of the two U's. So you go just above where you have the parity here, and go to U, to R, to F, and just one to U, then do to F, to R, to U, and then to F. That'll fix that, but it'll place the parity at right angles over here. So then what you do is you go to the other side and do the same parity algorithm, except now you have the two U's in the middle instead of the one U, and that'll fix that whole thing. To U, to R, to F, to UU, to U, to F, to R, to U, and then it's solved. So there you have it, the layer by layer by layer by layer by layer approach to the 4x4 by 5. This layer is easy, this one's easy, this one is pretty straightforward with a little bit of trickiness. This is the bare layer. This layer is also easy as long as you keep in mind that placement parity fixing algorithm. If there's any other questions regarding this puzzle or alternative ways of solving, or you'd like to see me do another reductive strategy with this, if things weren't clear with the first one, let me know. Thanks for watching.